I changed directory. And command line, you don't need to know all the stuff, but I just made a directory. It's called make directory. I could also have done that here, right click, new folder. I could have done that. So let me just create a new file name, file something. Well, what shall we do? I like to name my programs. Of course, we want it to be descriptive. I'm going to be somewhat barely descriptive here. But if we have multiple programs in a folder, ideally you want to know which is the main program that you want to run in a folder. So I like to usually call something main, blah, 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 whatever we are trying to do there. Or I often use root, R-O-O-T, first program. So I use the name of the program to signify, okay, that's the main program in this folder. Take a look at that first, kind of thing. So I like to say programming is an act of communicating, communicating not just to the computer, but also to the person reading the program. And the person reading the program might be yourself 2 years from now, 3 months from now, maybe 10 years from now, depending on what you're doing, I guess, in life. If you do not name things appropriately, the program you yourself wrote, even like a few weeks before, will be inscrutable. So I like to name my variables, comment my programs well, and so on. Okay. So I guess that's a general philosophical note, or best programming practices note more than anything else. Oops. Let me just look at the chat window here. I guess a whole bunch of people, I didn't look at the chat window, but a whole bunch of folks have written about their experience with MATLAB. Cool, good to know. Alex says, are there attendance points as shown in the gradebook? I wouldn't worry about it. Yeah, so I think on the syllabus I said something like, if you're reasonably regular, we'll give you full points on that with like submission of homeworks and things like that. So yeah, don't worry about it. Cool. Okay, so what we're going to do is sort of a very simple thing. We're going to do plotting of projectile motion. Something flying through the air and then I guess falling onto the ground. And then we are going to animate it, like actually show the movement. So that's sort of what we're going to do. And then if we have time, we'll actually start solving differential equations in MATLAB, I suppose. Okay, so just to give like a very basic introduction, I suppose in MATLAB, you can use the command line interface to create variables. You can say A equals 5, B equals 6, and C equals A times B. You can clear, which will clear all the variables, so that if you say A, I'll say unrecognized variable. And this was the workspace. This used to be the workspace. A has a value of 4. B has a value of, let's say, 3, 4, 5, 6. It's a matrix 3, 4, 5, 6. And you can create matrices like this if you want. And then you can go C equals A times B. And you get a new matrix C, which is the scalar A multiplied by the matrix B, or a scalar A multiplying the matrix B, and you get C. In any case, that's just sort of the basics in MATLAB. And you can do all that inside a program, sometimes called a script. And you all obviously want to, how should you start a script first? Okay, plotting and animating projectile motion. We're just going to say that's what we're going to do. Okay, you can put your name. That's certainly reasonable. If you want. And if you want, you can date it, but not super necessary. But okay. But yeah, so when you create a new program, the first thing you want to do, aside from maybe writing a couple of lines about what the program is about and maybe who wrote it, first do clear, so that if you don't do clear, for instance, if you had a equals 5, that a equals 5 would be accessible from this program if you did not do clear. So, and we don't know what else was run before, so you want to clear before you start. And then you want to do close all, which will close all the figures that are open, assuming you want to close all the figures to start afresh. Okay, so if you had a figure, I'm just going to create a figure here. Let me just create a random figure here. That's a figure that shows up, straight line. X-axis is 1 to 10, y-axis is 3 to 30. I did 3 times 1 colon 10. So it goes 3, like it takes 1 colon 10, the vector, and then multiplies all those numbers with 3, and that's the line that we got. But then if we do close all, that closes, okay? And sometimes it's useful to do CLC. CLC, what does CLC do? Yeah, so CLC does basically clears the screen here. So those 3 things are pretty sufficient overall for most purposes. Okay. Okay, so what we're going to do is animate projectile motion. Or plot projectile motion, I meant to say. Lots of ways of doing that. What I'm going to do is to just use the formula for projectile motion, where you have some initial velocity in the x direction and the y direction, and you have some list of times. And we are going to compute the velocity as a function of time, and then the position as a function of time. Just going to use like the formulas you guys learned in your, I don't know, physics class or something that we derived in our, just before our first homework in this course. So I'm going to create this thing called t-list, which is a variable, which is the list of time points. I'm going to use Linspace. Are people familiar with Linspace?
Yeah.
Okay, cool. So Linspace, you can do this where you go 0 colon 0.01 to 2 or something. It will create a vector from 0 in steps of 0.01 until 2. Alternatively, you can do a equals Linspace 0, 2, and how many ever points in between, either 10 points or 100 points, whatever, and it will create how many ever points between 0 and 2, okay? That are equally spaced. So that's convenient. I don't know, let's simulate it for 10 seconds, which might be too long, but maybe 100 points in between. And by default, it gives us a row vector. For some reason, I happen to like column vectors for visualizing, like on the screen. So how do you convert a row vector to a column vector?
Transpose it.
Say it again.
I'll just transpose.
Transpose, right? Transpose is in MATLAB. How do you do it?
Just like an apostrophe.
Apostrophe, that's right. So you put an apostrophe there. That's a transpose. Okay. So let's equally spaced time points. The apostrophe is for transpose row to column. Okay. Okay, so this is just that. Now let's actually write down some variables. Let's say Vx naught. Let's say initial position velocity. X naught, let's say we start from the origin, X naught equals 0, Y naught equal to 0. And then, now is the font size big enough? Should I increase the font size?
Maybe a little bit.
A little bigger, yeah. Cool. By the way, there's a sample sentence here. Do you guys know what the sample sentence signifies?
As like all the letters of the alphabet or something.
That's right, yeah. That's exactly right. So you can see what all the characters look like, I guess, in this font. Okay, hopefully that's big enough. So let's give it some initial velocity in the x direction and y direction. What shall we say? I don't know. What do you want? 1, 1. Okay, so that's that. We can plot, we can write down the expression for the position, the velocity, let's say velocity versus time. Let me call this Vx list, okay? I use the word list to indicate that this is not just a single number, but a whole list of things. This is just my sort of naming conventions for things. It just makes it clear to me. So there are things that are scalars or single numbers, which I don't use the word list for. And then things that are lists, I call them out as being lists, right? So that I generally say that writing a clear program that someone else can understand usually makes it easier for you to debug it when you are trying to, when you say, if I have a bug or anything like that. Okay. So what's going to be Vx list? What's the formula for Vx list given the initial velocity and time? Let's actually do Vy list first. What's Vy list? Do you guys remember the formula? So Vy list is going to be the initial Vy, and then it's going to basically linearly change in time. So it's basically going to be Vy naught minus G times T list. It's basically Vy naught minus GT is the formula for it. I'm not expecting you guys to remember the formula, so we can sort of, we derived it in the first homework, these things. So this is just sort of, you can look it up if you want or rederive it, but I'm just going to assume that these are the formulas, right? What is the velocity in the x direction? As a function of time.
Just be constant the whole
It's
time.
going to be a constant, that's right. So if you start with,
do you have to say what g is if you're going to use it as a variable?
Great. Very good. Yeah. So as you will notice, over the next few minutes, I will intentionally skip things and expect you guys to catch it, or we'll run it and then find the bug and then modify it. So that's going to be how it works. Yes, a couple of folks are saying initialize G, that's right. So good catch. What should we call it? 9.81. Okay, so very good. So this is a scalar, this is a scalar, this is a whole array of things, but essentially, so MATLAB will deal with this in a reasonable manner. It will take this scalar, multiply this with this vector, and basically scale the whole thing, take the negative of the whole thing, and then subtract from the scalar every single element of this array, and you will get an array output. Okay, so that's what will happen. And Vx list is it going to be Vx naught? Now, what's wrong with that? So doing that.
It's still a scalar and not a function of time.
Yeah, it's still a scalar. That's right. If you want to plot it versus time, this is still a single number. How do you convert it to a list? There's no, for these things, there's no single answer. There's probably 10 different ways of answering this question perfectly correctly, right?
You could make a vector of like ones and multiply it by it.
Okay, perfect. That works. So how do you make a vector of ones? There's a command called ones. And then if you go 3, 4, it makes a 3, 4 array of ones. Here, how do we want to do it? How many elements?
100.
100. We can do 100, 1 if you want. In general, you want to avoid these things like, you want to avoid numbers. So you want to say num points or something like that. And say num points equals 100. Because if we use num points again, like in 3 different places, we don't want to remember to use 100. Because if you have to do that, well, if you change the 100 to 200 here, you'll have to change in 5 different places. So ideally, like things you want to change, sometimes you want to make sure that they're defined at the top so that you only change it once. And 5, I don't know, t total duration or something. And then I'm going to replace this 5 with total duration. Okay, so that's good. This works. Are there alternatives? Looks like people have. Okay, so Heath says size. That's great as well. So this works. This will work. The thing that Heath mentioned on chat window will also work. You can say Vx naught times ones of size of t list. If you do that, that'll work. It'll just make grab the size of t list and make a list of ones that's exactly the size of t list, whatever it may be. That'll work. Again, a few different ways of doing this potentially. Another way of doing this, which is Vx list. Can you do something analogous to this to work that? So we can do something completely analogous. Instead of G, you can replace G with a 0 and then go T list. And that will work. Basically, it will start with this T list and then multiply all of those things with a 0. So you get a list of zeros, and you're subtracting a list of zeros from Vx naught. So that'll also work. Okay. Cool. Okay. So all these things will work. They will all give you the same answer. And we can plot, if you want, plot T list, comma, Vx list. Label is T, Y label is V sub X or something. You can run the whole thing. Vx is constant. If you want to plot two things on the same plot, how do you do it?
Hold on.
Hold on, that's right. Hold on. There's a couple of different ways of answering that question, but hold on is certainly one way to do it. And so I suppose now we have to change the Y label, unfortunately. I'm just going to say Y label Vx comma Vy or something like that. Okay, Vx looks like this, Vy looks like this. Now, if you want to tell which is Vx, which is Vy, what do we do in the program?
Make a legend.
Make a legend, that's right. Cool. So we can do Vx, Y. So that works. The fonts are a bit tiny. but you can actually change all that. So everything, every single aspect of this whatever figure can be changed if you want. You can change the line width to 3 or something. I don't know. Let's see if that works. Okay, so thicker lines. I think you might be able to change the font size here. Let's check if that works. Maybe not. Did it work? Okay, it worked. So font size, bigger font size there. Presumably that works. Okay, much bigger, much better. So really, in this case, I happen to remember it, but in general, I would just Google, hey, how do you change the font size of the labels on MATLAB or something like that. Google is your friend in these cases. Okay, so what do we do next? We can very quickly do positions. So I'm going to put a double percentage sign here. What does that do in MATLAB?
Creates different sections that can be run separately.
That's right. So there's this button called run section. If you put this double percentage sign, it separates these things into sections. You can run this section, then you can run this section, and then you can run this section. It's helpful for debugging, like running section by section, making a little bit of progress and checking along the way and so on. Okay, so let me just quickly do position as well. We'll just write the formula down. Xlist will be equal to x naught plus, let's do ylist again first. It's going to be, it turns out, vx naught times tlist plus minus. It's going to be basically, yeah, all this is y. It's initial y plus the initial velocity times t, vt, and then minus half gt square. Okay, minus half gt square. How do you do the gt square here in MATLAB? Right, so if you do tlist square, so tlist is this thing. It's a bunch of numbers from 0 to 5. If you do tlist square, it'll say error using power, incorrect dimensions for raising a matrix to power. Okay. Power basically in MATLAB means that you're doing this matrix multiplication. This is considered a matrix, this is considered a matrix. And these two matrices are not compatible for matrix multiplication. So it'll complain. So only square matrices can be raised to a power. But as folks are saying in the chat window, a couple of ways of doing it. Yeah, you can do dot raised to. So if you do tlist dot raised to 2, then what it will do is take each element and then raise it to a power 2. That's dot. It's different from the dot product in vector analysis. This is just the dot multiplication, I guess, in MATLAB. Or you can do tlist dot multiply tlist. You can do this where it will multiply the corresponding elements of the two matrices, which is different from matrix multiplication. If you recall, matrix multiplication is a more complicated thing. Okay, so that's what we do. Half g tlist to the power half. You can also put this in a loop if you want, where you can just go from I equals 1 to, you can use a for loop for go from y equals 1 to num points, and then go y list of I equals y naught plus vy naught times t list of I minus 0.5g half t list of I whole square. So I can sort of do element by element, totally fine. For much more complicated things, you may need to do that, as we will sort of soon do. But for these relatively simple formulas, you can sort of do a single sentence and avoid doing a loop. Okay, position, X list, it's going to be very similar. I'm just going to copy it, paste it, and change things to X. And this is a 0. There's no acceleration in the Y direction, in the X direction. And then let me do figure 2. The figure 2, let me do it differently from figure 1. In figure 1, we plotted both the lines on the same plot. Now let me plot it. Let's plot this thing in separate plots, but in the same figure window. How do you do that? Have people done subplots? Maybe some of you have. Okay, so you can do something called subplots, where you have two plots, 2, 1, 1. I'll explain what that is. And then you just go plot t list, X list, and then do the same thing. Okay, hopefully that works. We'll have to do 2 here. So what this does, as I'll explain it in a second, it creates this 2, 1 list of figures. So 2 rows, 1 column list of figures. And then you're saying, let's plot now in the first one of those 2 figures. And then let's plot in the second one of those 2 figures. Probably better to do 1, 2, probably looks nicer. Maybe, I don't know. Actually, either is fine. Yeah. The fonts are still a bit small, but that's okay for now. Any questions so far? Okay, so let me do figure 3. Let me just plot X list versus Y list and just say X label. I'm just copy and pasting that. So this is the parabolic path. Okay, it starts at X equal to 0, Y equal to 0. You can zoom in, and it sort of goes at a 45-degree angle, I think, but just sort of eventually goes underground. It goes to negative Y values eventually. So how do you fix that? So in about 5 seconds, it's gone to negative 120 meters. So let's just simulate it for 2 seconds. Maybe simulate it for 1 second. Maybe increase the velocity a bit. Now let me simulate it for 2 seconds. Okay, so you throw it up in the air, and then it follows this parabolic path. And then if you keep plotting it, of course, it'll eventually go under the ground because the equations don't know that there is a ground here. Well, if you extend time beyond whatever, whenever that strikes the ground, it'll just keep going down underneath the ground, right? What does subplot do? Subplot, yeah, I guess we saw, I don't know if that was an older question, but it essentially creates these multiple plots within a single plot. Okay, so let's see if we can make an animation now. Okay, so that's the final piece. We're going to be will be done in about 10-15 minutes. So what we want to do is essentially do an animation of X list versus Y list. So you want to see a ball going through the air. And well, I guess that's that. That's all we want to see perhaps first. So let's try that. How do we do that? So again, there's a couple of ways of doing this. So hopefully most of what we did so far is review. And maybe this animation stuff is not quite review, but maybe to a couple of folks it is. But so there's a couple of ways of doing this. One is, okay, let's guess how would we do it? How would we do an animation? How would we do an animation? Alexander says pause, draw now. Kind of. I think what you're implicitly sort of saying is that sort of put the ball in a loop, sort of keep plotting it, and then pause for a while and keep plotting the new position of the ball. Okay, just going back to the question that Rohan asked in the chat window, what do the arguments in the function call mean in the subplot? Okay, so the first two arguments, this 1, 2, sorry, I think I messed this up here when I was changing too many things too quickly. But the first two arguments basically indicate how many plots should you create and what is the matrix of plots you should create. So if you do sort of 3, 4 or something, you're not going to do this, but basically it creates 3 rows of plots and 4 columns of plots. And then, so that's the meaning of the first two arguments. Like what is the matrix? How many plots do you want to create? And then this 1, 2, and so on indicates which of these 12 plots do you actually want to plot in. So you're plotting the first plot, you're plotting the second plot, and if you had 10 more plots, you can keep going, plot, third plot, fourth plot, fifth plot, sixth plot, etc. So subplot, quite useful, yeah. But for now, I guess we just need 2 plots. So we just go 1, 2 or 2, 1, whichever you want to do, I suppose. By the way, there's something kind of wrong with this picture. I suppose we'll get to this when we do the animation. There's something that is subtly not quite right, in my opinion. Okay, so if you can think of that, well, think about it. Okay, so animation is just going plot, plot, plot in a loop. Okay, so that's method 1. And then method 2 is what is called handle graphics. We'll do the plot, plot, plot version because that's simpler. And then I'll show you how to do the handle graphics as well. So basically, we're going to loop. We're going to say for I, whatever, I loop equals 1 to num points because we are going to do this plot so many times. And then we are going to plot. What are we going to plot? We're going to plot X list of I basically and Y list of I, right? So we're just going to plot the ith time points position. Again, I use a longer word than sort of typical or necessary here. People often would do I. I could call this iframe or something as a frame of animation or a frame of a movie. When you have a long, complicated program and you have lots of loops all over the place, the loop index variable, it's better to have some meaning associated with the name of the variable. Like, what are you iterating over? Like, if you're processing, I don't know, data from a number of people, maybe you want to do I people or I person or something like that. Sort of conveying what you're looping over is useful. Because if they're just sort of I's floating around for multiple different loops, then that's a potential trap for bugs. Okay, so Mackenzie asks, will I post this MATLAB file? Absolutely, yes. I will post this MATLAB file on Carmen as well. I'll post this video as well as the MATLAB file. Okay, so we've put a plot. Let's just run it. So here's where I'm going to intentionally miss a few things. We'll run it and see how it's horrible, and then fix the ways in which it is horrible. Okay, so what have we done here? Well, let's go first of all figure 4 or something. Let's do a new figure. Let's run it, see what happens. Okay, the thing ran and you just got this blank screen. What should you do? So Alexander, I think, already gave part of an answer there on the chat window. Hold on. So let's try the hold on thing. Hold on is going to produce an interesting effect. Perhaps it's the effect that we want, perhaps not. It really depends on what you want. Okay, so let's do. Okay, so nothing seems to have appeared on the screen. What's wrong? Okay, so I think when you do it like this, it plots a point, but a point that is too small. So let's put an O there. Okay, so basically, if you don't specify a symbol, it puts a point there, but the point is way too small, so you can barely see it. So you can, if you actually put a marker, you get a bigger sort of marker. Okay, so what's wrong with this now? Okay, so Mustafa says, pause, too fast. Yes, so let's put a pause here. And we will revisit the hold on. Let me put a pause for 1/100th of a second. Alexander says axis changes every iteration. That we'll fix in a minute. It's a good point. Okay, so that's the thing that Alexander mentioned, I guess. The axis changed, like initially it was something, and then the axis enlarged to accommodate the full plot. How do you fix that? So you can do something, you can actually specify the axes. You can say xlim. We can just say 0 to 20, let's say, and then ylim. Let's say 0 to 6. That basically fixes the axis. Kind of looks weird. Okay, so it seems to have missed some points even. Not sure what that's about. Okay, so what else can we fix? Let me run this again. So really funny thing seems to have happened. These missing points seem to have appeared on this plot. A few appear to have seem to have appeared on this plot. Okay, yeah. Okay, so there's a command called draw now, which so the MATLAB just processes these things so fast, and actually processes some of these things asynchronously, not necessarily in order. So it does sometimes these weird things where things will appear on a different plot and so on. So the pause is good, but sort of more importantly, you need a draw now, which basically says to MATLAB, hey, slow down, finish this plot, and then go to the next sort of iteration. That will make things better. Okay. Okay, much better. Hopefully you can see this in the screen share. Yeah, so Mazen got that as well, the missing plots and the other figures. Okay, so that was a sort of a cleaner thing. There are a couple of more things. While each one is a different color, maybe we don't want it to be a different color. Let them, I don't know, make them all blue, I don't know, red or something. Okay, and maybe like, do we want hold on or hold off? I guess, do we want to see the whole trail of points or just a single ball flying through the air? So if you just want a single ball flying through the air, you remove the hold on, and that's what that looks like. Hopefully people can see it. You can actually, if you want to make it more visible, you can change properties of this. Marker face color. You can make it, I don't know, also red or black. Perhaps that looks better. We can increase the marker size to, I don't know what the size is right now, but bigger ball flying through the air. What else can we change? There's a couple of more things. Maybe we want, well, okay, so there's something wrong with this animation that I sort of alluded to earlier, but didn't sort of address it yet. There's something weird about this animation. Any guesses? The weirdness was shared by the previous plot as well. It doesn't start at 0. Says, let's check that. We'll have to see that if that's true. It seems to start at 0, I guess. At least on what I'm looking at, it seems to start at 0. It's quite possible that Zoom is dropping frames, so maybe you're not able to see it. So you should run this program at home because it's smoother for me than perhaps it is for you because of the Zoom issues. So the one thing that is actually not quite right about this plot or this animation is that notice the axis scale, right? So from here to here is 6 meters. From here to here is 20 meters, right? If you're plotting some visualization of the real world, the X scale should be the same as the Y scale so that you're not stretching the real world, right? So if a person was walking along here and the scale was true, we would be like stretching the person vertically, right? So in this case, we can't tell because it's a ball and MATLAB, and you say, oh, it just plots a circle, whatever the scale is. But if you're plotting a person, the person would have been stretched to, I don't know, some weird aspect ratio. Okay, so we want to actually do something called axis equal. So axis equal ensures that the X scale is the same as the Y scale. The scale is different from the limits of X and Y, right? So the limits are 0 to 6 and 0 to 20, but the scale is like, does this 1 unit correspond to 1 unit here? And that is ensured by axis equal. This needs to come before the xlim ylem, because it turns out that if you put xlim ylem before axis equal will take precedence and will sort of wipe out anything that you set with xlim ylem. So let's try that. So this is actually the real picture. This is what's really happening in the world for this ball. Let's take one more minute. Okay, let me make the ball much bigger as someone is asking. Okay. So maybe you want to plot a trail, right? So maybe we don't want to have the whole thing, but we want to plot a trail that is the trajectory from initial to where you are right now. How do you do that? Okay, so let me just do it. You have to go plot. Instead of doing X list, Y list, we have to plot X list of 1 to I frame, Y list of 1 to I frame. And then let me do line width 3 or something. If I do this, you'll have to do hold on, hold off. I guess we've sort of run out of time, so I'm just going to do that very quickly. I'm going to say hold on, and then after the pause, I'm going to say hold off, because we plotted multiple things and we have to turn off and turn on the hold on and hold off appropriately so that you don't overwrite, but you also. So that's the trajectory with the trail. Okay, so I guess we'll stop there and catch you guys next time.